So yesterday we started kinematics, and I told you that kinematics is basically, as the name suggests, a study of motion, regardless of the force behind that. If we involve the discussion of the force as well, it becomes dynamics. That will be the third unit. In this unit, we are just going to talk about motion only. And yesterday we discussed how, just actually reviewed, position, displacement, distance, velocity, speed, and the difference between these things. And I hope at this point you are very comfortable with these concepts. We learned position, time graph, and try to get different information out of it. And that was quite a good exercise. Today we are going to talk about velocity time graph, another important graph. In the position time graph, the slope of the graph was velocity, and over here it is acceleration. Because what is a slope? Slope is basically y component divided by x component, and we have velocity on the y side, and we have time on the x side. So velocity divided by time is acceleration. Now the question is, what is acceleration? We'll come back to that and explain that in detail. But just a brief idea. You have a gas pedal in your car, and in the technical term we call it accelerator. What is its job? It speeds up the car. Actually, you have two accelerators at that same place. One is the positive accelerator that is used to speed up the car, and that is your accelerator or gas pedal. And other is the brake, that is negative accelerator. So it is to bring the speed down a bit. So that is the brake. Brake is also, you can say, a decelerator. But again, for now it is enough, and A is equal to, just like velocity was final position minus initial position divided by time. Similarly, acceleration is final velocity minus initial velocity divided by time. Remember, it is always final minus initial. When you are trying to figure out a change, it always has to be final value minus initial value. Okay. So it means that if we can actually draw units, we can figure units from the formula. We know from this formula over here. Let me get a pointer over here. So we have velocity is equal to final velocity minus initial velocity divided by time. So what is the position. Final position minus initial position divided by time. How do we define position? We actually, it is not really position. You can say that it is basically displacement from the origin. So final displacement minus minus initial displacement divided by time. So what is the unit of displacement? That is meters. So if we subtract certain meters from certain meters, the answer will be meters. For example, 5 meters minus 8 meters is equal to minus 3 meters. So for the numerator over here, the unit is meters. What about the denominator? It is time. Unit of time is seconds. So if we check the unit of the whole thing, it is meters divided by second, or you can call it meter per second, and that is the unit of the quantity. On the other side, velocity. Velocity is meter per second. So if you don't know the units of something, but if you have the formula, you can use that formula to derive, to figure the units of that quantity. So here we have a meter per second, and now we are going to use the same technique to find out the units of acceleration. No, never miles per hour. In the US, yes, but in science, never. It is always kilometer per hour. Oh, sorry, meter per second, standard. Acceleration here. So Vf minus Vi, you are subtracting final velocity minus initial velocity. So what is the unit of the numerator? It is meter per second minus meter per second. It is certain meter per second. For example, if something is moving at 2 meter per second and it increases its speed or velocity to 8 meter per second, what is the difference in velocity? It is 8 minus 2 is equal to 6, right? So 6 meter per second is the answer for the numerator, and for denominator, the unit is seconds. So meter per second per second, or meter per second divided by second. So when we simplify that, we come up with this unit, meter per second squared. So unit of acceleration is meter per second or meter per second squared, both same. Now look at this plot here. So in this particular case, remember, in position time plot, our scope was starting a bit later, not from origin. But here, our scope is starting right from the origin. Our first point of observation, A, is at 0, 0, right? So at point A, some object, let's say it is a person, or it is a car, okay? So the car has a velocity of 0 meter per second. It is parked. It is stationary. And then we start our stopwatch, and then we start the car. It goes very steadily from A to B. So do you think that, I need a yes or no answer. Look at this plot, look at this information. Do you think that the car was moving at a constant speed steadily from A to B? Do you think so or not? Quick please. Okay. 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 Okay, we can say that it was accelerating steadily, but it was not moving steadily, because if you look at the velocity is changing. It is stationary at A, but it has increased to 7 meter per second by the time it has reached the point B. If the point B is not a position, it is just a point in the velocity time plot. You can say that it is an event of recording the information, okay? So you have a stopwatch, and at some certain events, you are recording the values. So at 3 seconds, you can say the velocity, the B actually determines the information at 3rd second. And at 3rd second, the velocity is 7 meter per second. From 0 to 7, the car has accelerated steadily. It was not a constant speed, not a constant velocity. Okay, at about 1 second, it was almost 2.5 meter per second. At about 2 seconds, it was almost 4.6 meter per second. And at the 3rd second, it has reached 7 meter per second. So it is increasing its velocity steadily. From B to C, do you think that velocity is constant or not? Excellent. Yes, from B to C it is constant. It is constant 7 meter per second. It is not changing at all. And from C to D, is it speeding up or slowing down? Awesome. So you are reading the plot just right. From C to D, it is slowing down, so we call it deceleration. Acceleration, deceleration. D to E, it is again constant, it is stable, and from E to F, it decelerates again, and it reaches 0 meter per second. So the scope of our problem here is from the point A. So again, point A is not a position. Okay, it is an event. It is the reading. It tells you, it describes you the reading taken at 0 second. Point B tells you the reading taken at 2 second time. So from 3 second time. From 0 to 3 seconds, A to B, the velocity increases constantly. Then it gets stable. Then it slows down. Then stable. Again slows down. So this is our scope. Excellent. What is the physical significance of the area under a velocity time curve? Usually, because this is something we are talking about for the first time, so you just throw a dart and just make a wild guess with all the information you have. So let's start with the very basic information we have. Area. What is the area? What is the simplest area we know? Rectangle? Square? Let's talk about rectangle. Area of rectangle is one side multiplied by the other side, right? Length multiplied by width. And similarly, area of the square is because square has all four sides equal, so it is just one side multiplied by other side. Basically, it is one dimension multiplied by other dimension for a two-dimensional object. For triangle, it gets a bit tricky, but I'll explain you that is also following the same procedure. One dimension multiplied by other dimension. So over here, our one dimension stable as it is not changing. Yes, stable means it's constant. Yeah, it is constant, unchanged. Good question. So for the area under this curve, it means that we are talking about something like area of this, right, or area of this, or the area under CD, or the area under AB, or under EF. Because BC and DE are simple cases, so I'm just going to use those first. These are simple rectangles. So what will be the area of this rectangle? What is and remember, this rectangle is not the shape rectangle. It is the area on a curve, under a curve, on a velocity time graph. So we are talking about totally another world. So now you can see that our understanding of the shapes becomes totally irrelevant over here. We are talking about a rectangle that is not a rectangular cut piece of wood or paper. It is not a rectangular shape. It is just a rectangular region under a curve. Okay? So remember that. It is not something you could cut. It is its one side is not 3 meters or 5 meters. It is velocity. Its other side is again not 5 meters, 6 meters. It is time. Okay? So when you multiply velocity by time, what do you get? Again, we use the simple trick of the units. Velocity is in meter per second and time is in seconds. If you multiply meter per second by seconds, seconds cancelled out, you are left with meters. And what quantity is in meters? Is that velocity, acceleration, or displacement? What do you think? It is displacement. So physical significance of the area under this curve is that this is actually telling, if you find out the area of this big rectangle, it will tell you the displacement from during this B to C. If you find the angle and the area of rectangle under DE, it will give you the value of displacement from D to E during between these two intervals. If you could not understand any point in this discussion, please let me know. I'll explain again, otherwise we'll move to next step. Okay, looks like all clear. Very good. Now let's talk about this. Maria, I don't know if yes means all clear or yes means I need to repeat. Now let's talk about triangle. Okay, very good. Thank you. So we know that for this triangle, the area of this triangle is the formula. What we have is 1/2 multiplied by h multiplied by the base. Okay. So we have the base let me just draw these lines. This is our base, and this is the height. So it is quite interesting that the sides, other two sides are not really involved in this formula. Okay, now where is this coming from? This is actually again area of rectangle. Okay, and then we have half of the area of rectangle. So what is actually going on? If I take this point, this from here, and I bring it there. Actually, I'm trying to flip it, and it is not giving me the option to do that. So I'm going to draw another line like this. Okay, that is what I have. Let me let's address this a different way, and that will be easier. So what I do, I'm going to change the color here. Now let's extend these areas over here. So this is one area, and then this is other area. Now we have two rectangles, right? And our favorite triangle is in the middle. So what I am going to do, I am going to solve this because I know the formula for the rectangle. Rectangle area is just multiplying this side by this side. So you can see here clearly. Let me mark this region over this one. This part of the rectangle triangle over here, this one, isn't that exactly the half of the area of this rectangle? Right? Because it is a diagonal, so it is essentially dividing the whole rectangle into two pieces. And same thing is happening over here, right? So now you can see that for this part of the triangle, the area of this half of the triangle is half of this rectangle. So what is the area of this rectangle? This side multiplied with that side, and this side over here and over here, both are the heights. These are the same as the height of this triangle, right? And this base of this side of this rectangle and this side of this rectangle, if you add these, this becomes the base of the triangle, and then you have to have to divide by 2 the area of both rectangles. So that is where the half is coming from. So now you can see how it directly related to the area of the rectangle. You just need to extend the problem and introduce some imaginary rectangle, and you just get there very quick. But you should know that half multiplied by the height multiplied by the base. This is the area of triangle. I'll try to provide that in the exam, but I don't guarantee, so you should know that. Now let's talk about the area under the curve. So first we need to mark the areas. What are those regions? Because what I may want to find out the displacement during the interval A to B, or B to D, or A to E, or A to F, whatever. So whatever is my choice, whatever is my scope, I need to know the area under the curve. So let's do it for A to F, okay, and mark all the areas we need to find out. So for B to A, this is the area you need to find out. So area is very simple over here. Half multiplied by 7, the height of the triangle, multiply with the base, that is 3. So that will be 21 divided by 2. It will be 10 and a half. Okay. Second is area of this rectangle. And that is very simple, 7. Because one side of this rectangle is 7, other side is 3, so it will be 7 multiplied by 3, 21. So 21 meters is the displacement in this scope. C to D, that is a bit tricky. Why? Because it has two shapes you need to consider. One is this triangle, and other is this rectangle. Okay. So for the area under this curve, you have to find out the area of this triangle first. That will be 4 multiplied by 2 divided by 2 equal to 4. And then area of this rectangle, that will be 3 multiplied by 2, 6. So that will give you the displacement. And then area of, sorry, I lost the rectangle. This rectangle, again, 3 multiplied by 2 is equal to 6. And then the last one is the area of this triangle, that is 3 multiplied by 2 divided by 2 is equal to 3. So if you add all these areas, you will have the displacement during all this motion. So let's solve this one over here. For A to B, area of the triangle is half multiplied by base multiplied by perpendicular. And why, I just explained that. This is covered or displacement to be specific. Because if the motion is along the straight line, then magnitude of the displacement is equal to distance. So sometimes it is not very good idea, but sometimes we use these words interchangeably in these particular situations. But again, try to avoid that, but I couldn't avoid that in the slides, sorry for that. Third, between A and B. So one side is half just there, base is 3, height of the triangle is 7, so area under A to B is 10.5. So as the car was stationary at this point, and then it started speeding up and it reached this point, at third second its velocity was 7 meters per second. During all this transition, it has already gone through 10.5 meters displacement. This is what it means, okay? In exam, I can give you this kind of figure, and I can ask you what is the displacement between B and E, these two intervals. So all you have to do, find the area of this, area under this, and area under this. Add those, and you have the answer. Because you can say if there was a point between A and B parallel, would the same formula still apply for displacement? A point to B. You are asking if it was just like this on the same line, like this. Oh, near 7. On the same line, or on the side, or somewhere else? Where? But near y-axis. I'm sorry, possibly you have to near 7 on y-axis. Okay, if I had another point coinciding there, okay, now let's do it mathematically. What should be the x-coordinate, the time coordinate of the point you are suggesting? Should be 1, 2, 3, 4, 5, which one? 0.7 is over here. Is this what you mean? Okay. Now you are saying that if it was going like this and then this. Yeah, I got it. I got it. Okay. So this is a situation you are suggesting? Okay. It will be the same thing. Again, if you want to, if you are actually shifting B, you are changing B instead of being at 3, now we are taking our second reading at 0.7 second, and by that time the car has already gone 7 meters per second. So what is the displacement? Yes, this is what we are going to do. Half multiplied by 0.7 multiplied by 7. So it will be 4.9 divided by 2, about 2.4. Is that your question? Okay. Another question was, Maria, how would you solve from B to E? B to E. Okay. I just explained that. So we have one solved already for B to C. Okay. The second one you need to solve is D to E. The third one you need to solve is this one, and another you need to solve is this one. So let's mark these 1, and this is our 2, and this is our 3, and this is 4. I hope you know Roman numerals, that are very interesting. And this is our 5. So we have 5 regions. Oh, sorry, B to E, not B to F. Sorry, so we can get rid of this last one. Okay, B to E. Now, what is the area of the first section? We already know that, 10.5. Now let's begin with the second. Second is CD on the top one, the triangle. So area 2, no, okay, is equal to 1 by 2 multiplied by the side over here. Over here is 4 and the base is 2. So it will be 4 multiplied by 2 is equal to, and just 4. Let's okay. With this shifts and scale them and so yeah, good. Now let's talk about area 3 is equal to, it is just rectangle, so very easy to solve. One side is 3, other side is 2, the answer will be 6. So 3 multiplied by 2 is equal to 6. And one thing I am committing, I should not, it is always give the full information, meters as well. So what is the area 4? Area 4 is over here. It is again, area 2 is 4. Yeah. 1, 2, 3, 4, multiplied by 2, 8. 8 divided by 2 is equal to 4. Yeah. No, area 1, 2, 3. We have 4 boxes over here. Yeah. Okay. Now, area 4 over here. It is 3 multiplied by 2, same as area 3. So 3 multiplied by 2 is equal to 6. So the total area, total displacement from 3 seconds to 10 seconds is equal to 4 plus 6 plus 6 is equal to 16 meters. So that's how you solve it. Any question or confusion? If the motion is along a straight line, then distance and displacement will be the same. But this is because we have velocity on the y-axis, then of course it will, and the exact information that is coming out of it is displacement directly. With speed, it may be a bit tricky. I'm not really sure if a speed time curve will give you the same information. It should. I have not tried that yet, so I cannot claim it. Jennifer, you said no. I guess it was the answer when I asked if you have any question. If we have speed, yeah, okay, good. Okay, now the fun time. This is what I love. Today we are not going to take any break, right? Bad news. The good news is we'll finish at 8:50, maybe faster. Okay, now we have 3 tools in kinematics, and these tools are beautiful. And you will be, once you understand how to use, where to use these tools, you will love it. These are 3 equations of motion. The first equation of motion, and in the exam you will be given these equations. You don't need to memorize, but I can guarantee that I'll throw so many questions on you that you will memorize these anyway. So the first equation of motion is Vf is equal to Vi plus At. Vf is final velocity, Vi is initial velocity, A is acceleration, and T is time. So this equation just tells you that if at any instance some object is moving at velocity Vi, and it has acceleration A, it goes through acceleration A within the time t seconds, its velocity will increase to Vf. And actually this is coming from the definition of acceleration, because if you rearrange that, it will be Vf minus Vi divided by t is equal to A. That is acceleration, right? So this is first equation of motion, and this equation relates 4 parameters: Vf, Vi, A, T. For all these equations, all 3 equations, these equations deal with total 5 variables, okay? Vf, Vi, A, T, and S. And each equation connects 4 out of these 5. So first equation is connecting Vf, Vi, A, and T, but it is not involving S. Now second equation, S is equal to VIT plus half AT squared. So this equation is connecting S, which is displacement. Sorry, I didn't explain that. S is displacement. So it is connecting displacement, initial velocity, time, and acceleration, but Vf is missing here, right? Now, third equation, 2AS is equal to Vf squared minus Vi squared. It is not involving time, but it is connecting acceleration, displacement, initial velocity, final velocity. So these are the basic, you can see properties of characteristics of these equations. There are total 5 variables: S, Vi, Vf, A, and T. These are important variables in kinematics. Each equation is going to connect 4 out of these. And when I am saying this again and again, because this is very important information you need to have. Once you are ready to solve a problem, this is what you need to figure out. Okay, what 4 variables this problem is dealing with? So once you have those 4 variables, then you can come back to this slide and you can say, okay, what tools am I going to use? It is just like using a drill bit with a drill machine with different assemblies, different attachments, or a screwdriver with different attachments. You look at the screw, you say, okay, it is flat, Phillips, whatever, and then you go back and you connect the screwdriver with the proper attachment, and then you deal with the screw. So same thing is going to happen here. We look at a problem. Okay, what kind of problem is that? Okay, we need second equation, maybe third equation, maybe first equation. You use that attachment and you solve the problem. So problem solving strategy. Now we are going to dive deep into numericals, into mathematical problems. The strategy is, first of all, read the problem. Sometimes the information is readily available in the problem. It is bright, clear, you can read that. Sometimes it is hidden under the words. And I'll show you how to find that out. Identify known and given variables. So this is the first thing you need to do. Second is identify unknown or to be determined variables. Unknown doesn't mean that whatever is not known, mass, weight. No, we're talking about the problem. So in the problem, it will tell you that, okay, do we need to find initial velocity? Do we need to find time? Do we need time acceleration? What? So this is what you need to identify. And then use appropriate equation of motion and you'll have your problem solved. Look at this one here. So this is kind of your Swiss Army knife. This is the word I like to use about that. Variables are initial velocity, VI, final velocity, VF, distance traveled, S, acceleration, A. So if we have let's go there. While solving kinematics problem, you need to look at 4 out of 5 variables. As I told you, there are total of 5. And each equation deals with 4 out of 5. So let's read this problem. A car is moving with velocity 5 meters per second. VIVF, final initial, it is basically about the scope. So just when you are reading the problem, imagine yourself standing on the roadside watching this thing happening with a stopwatch in your hand. You are the observers. You are the one taking these readings. So now, a car is moving with velocity 5 meters per second. It may be moving at 10 meters per second or 3 meters per second or maybe just park a few seconds before this instance. But that is beyond our scope. Our scope starts when the problem tells us a car is moving with velocity 5 meters per second. That is where you started taking the reading. Okay? So this is a very important concept. What is your scope? Whatever was happening before that, we don't care. Okay. Now, a car is moving with velocity 5 meters per second. It is, of course, it is velocity, but what velocity is that? Is that final velocity or initial velocity? Because we have just started reading this, of course, it is initial velocity, okay? After applying brakes, it comes to rest. Now you see, I'm not saying that its final velocity is 0 meters per second. I'm just saying it comes to rest. It means that it's the moment my scope closes or limits. What is the velocity at that point? It is 0 meters per second. It has come to rest. So initial velocity is 5 meters per second, final velocity is 0 meters per second. So we have 2 variables right there. In 5 seconds. So we have now a third variable, that is time, 5 seconds. Okay. So now just try to imagine that. Your imagination should be very good for this kind of problem. The car is moving at 5 meters per second. It applies brake and starts slowing down and comes to rest in 5 seconds. So from the event, it was at 5 meters per second, to the event, it comes to a complete stop. The whole thing happens within 5 seconds. Okay? So the time is 5 seconds. Find acceleration. What is the acceleration? Of course, the velocity was changing. It was decreasing, but it was changing. So there is some change in velocity. There is some acceleration. Physically, we can tell that acceleration will be negative because something was slowing down, right? Vf minus Vi divided by t. So the time is the another known, and acceleration is the unknown that we need to find out. So we have 4 variables right there: Vi, Vf, t, and a. And f, displacement, we don't care. There is no mention of that in the statement, so that is out. Now the 4 variables we're dealing with, Vf, Vi, A, and T. Now let's go back and let me grab a screenshot of this. and then you are going to help me find out, the proper tool for that. And this is our variable. Copy, go back, and paste. Now tell me which tool is going to help me. First, second, or third? Which equation? Any other? Teresa, Stacy, Nikki. Okay, good. Okay, very good. Yes, it is going to be first equation of motion. So, if you have figured this out, you have already learned half of the what you need to learn to solve the problems. So VI, VF, A, and T, good match. First equation of motion is what you are going to use to solve that problem. Okay, look at this one. Equation of motion while solving her again. A stone initially at rest. Okay, what is it telling me? Tell me what variable is that and what is the value. Please tell me that. I need the answer. No, at rest. I have highlighted that in red. Okay, V, which one? Which V? We have two V's, VI and VF. Okay. Okay, not V1. We are going to use this convention, VI, for now. V1 is good, okay, for now. VI is equal to 0. Excellent, very good. So, initially at rest, our scopes start at that point. And we just started paying attention to that stone. So, this is where we start our scope. A stone initially at rest, it means that VI is equal to 0. Is dropped. Okay, this is something you don't know, but I'm going to help you with that. When something is dropped, it falls under the influence of gravitational acceleration. Okay, gravitational acceleration is 9.8 meter per second squared. In physics 1 and 2, will not use 9.8, we'll use 10 meter per second squared for the sake of simplicity. Okay, so for physics 1, physics 2 again, our value of G is gravitational acceleration, and the value of G will be 10 meter per second squared. What does that really mean? It means that if you drop something, of course, we know that initially it is at rest, you drop it, and if you do that, like from 9th or 10th floor, you'll see the significance of what I'm going to tell you. Its velocity increases by 10 meter per second after each second. Okay? If we use the 9.8 meter per second squared, it means that its velocity will increase by 9.8 meter per second in each second. That's why it is mandatory to put those hard hats on when you are in a construction area, because a little small screwdriver, if it is coming from 100 meter per second, now just imagine, if its velocity is increasing by 10 meter per second after each second, what can it do to you? Now let's jump back to our agreed upon value, or you can say imposed value of G. Gravitational acceleration is G. We use the letter A for acceleration, but gravitational acceleration is a special one, and we call it G. Okay, so G is equal to 10 meter per second squared. Now let me give you some idea of what do I mean. If you invoke your Google Calendar and you just type in 20 meter per second to kilometer per hour, or if you are in states, you can use miles per hour. So it is equal to 44 miles per hour, 20 meter per second. 20 meter per second is equal to 44 miles per hour, or if you are in Canada, it is 72 kilometers per hour. And This will happen within 2 seconds, because after 1 second, its velocity will increase from 0 to 10. After another second, it will increase from 10 to 20. Within 2 seconds, the object will get the speed, the velocity of 72 km per hour or 44 or 45 miles per hour. This is what happens. So again, now you can think that if you are in a construction area and even a small object, some small plier or something like that, it falls from a height, it takes 2 seconds to reach your skull. It hits your skull at 45 miles per hour or 72 kilometers per hour. What will happen? So these safety measures are for some reason. Okay, it is dropped, so we know that A is equal to 10 meters per second squared. Okay, from 50 meter height, what is that? Is that A or T or S or VF? What is that? 50 meter height. There is no D. Your answer is correct, but we have to pick one from these 5. So it is S. Yeah. Okay. So yes, it is a displacement. Okay. This is the total fall it is going to go through. So S is equal to 50 meters. How long will it take? What variable are we talking about? VS, VI, A, T, or S? Okay. Anyone else? Please answer quickly. It is a very simple question. And if it is a simple question, it should tell you, I need to answer that quickly. Not that, okay, we know that, it's understood. No, don't do that. Answer it quickly. So it is time. Good. So we have the variables now. VI is equal to 0, and A is equal to G is equal to 10 meters per second squared. S is equal to 50 meters, and time, this is what we need to know. So that's underlined. VI, we know that. A, we know that. 50 meter height, we know that. And the time is unknown. So which, let me again take a screenshot and take it to that slide. Now which one? Which equation is going to help us? Okay. Any other? Please be quick. So it will be second equation of motion. Very good, because that is where we are dealing with. Yeah, good. Thank you. VI, A, T, and S. Excellent. Okay. So this first is done. Now let's start. Okay, this is another example where a lot of information is hidden. You see only one number, but of course from this statement you are going to find out 4 variables at least. A stone is thrown straight upward. Again, what kind of acceleration we are dealing with? It is gravitational acceleration. Very good. But because it is thrown straight upward, it will be minus 10 meters per second squared. It is going to slow down. If we throw something upward, we throw at an initial increased velocity, then it slows down, and it reaches the final height where its velocity becomes 0 for a moment, and then it starts coming back. When it starts coming back, its acceleration is again positive because its velocity is increasing. This should be very clear by now that if velocity is increasing, acceleration will be a positive number. If velocity is decreasing, the acceleration will be a negative number because it is always Vf minus Vi divided by T. So if Vf is a smaller number, then we are getting the negative answer. Okay. So thrown straight upward, it means that we know A is minus 10 meters per second squared. Then, with initial velocity of 100 meters per second, what is the other piece of information we have? S is unknown. We need to find that out. But the second piece, I'm not getting answers from the class, so it is getting boring. This is very interesting, but I don't know why are you not participating. So please do. Okay. So initial velocity is 100 meters per second. So it is okay. That's fine. So initial velocity is VI. Okay. So VI A S. Now there is one information you will be using that during when solving this kind of problems. For the object thrown straight upward, oh, okay, thank you. For the objects thrown straight upward, velocity will be 0 at maximum height. I just explained the situation to you. If you throw something straight upward, it slows down, reaches the highest point. It stops there for a moment. So that is the top, the highest point, its climax. At that point, Vf is equal to 0. Okay? So that is the characteristic of this very point. So if I'm asking you that if something is thrown straight upward, what is the maximum height? We already know one information indirectly that Vf is equal to 0 at that point. Okay? Exactly, Kusika. Very good. So we have Vf is equal to 0 as well. So now again you have 4 variables and you can use the equation that you need to find out. Next thing here. A car accelerates steadily so that its velocity changes from 20 meters per second to 40 meters per second. What is t? Wait a second, let me go back. T is irrelevant. It is not even in the discussion. We don't care. It's not given, and we don't need to find that out. So that is the 5th out of these 5 that is out of this discussion. Okay. But if we change the statement, and if you need to find out time, you can do that too. Just pick the appropriate equation. Okay. I'm going backward. Sorry. Yeah. Okay. Now let's write down the information. So I start reading. A car accelerates steadily so that its velocity changes from 20 meters per second to 40 meters per second in 4 seconds. Now, what is the first piece of information we have? We'll go in sequence. So what is the first piece of, okay, Vi is equal to 20 meters per second, Ms is Vi, okay. Who else? Vi, okay. Excellent. So we have Vi, I'm going to use uppercase V just to highlight that. Okay, Vi is equal to 20 meters per second. What is the second piece of information in this statement? Okay. Excellent. So we have Vf is equal to 40 meters per second. What is the third piece of information in this statement? Very good. T is equal to 4 seconds. And what is the fourth piece that we need to find out? Emma, when you don't press the shift key harder. Okay. Fourth, piece is right here. Why are you going to the next part? This is a different part of the problem. Okay? So this is immediately the fourth piece that we need to find out. So once we find out acceleration, then we'll in the part B we'll solve the distance. So okay, so unknown over here is A is equal to unknown, and let me go back, and this time I grab this information, new copy, and no, okay, paste. So which equation is going to help you solving this problem? Third, VF, VI, A, and T. It is first equation. Okay, I told you that this part, I know where, maybe I know where the confusion is coming from. This is the second part of the problem. Okay, for now we are not solving that. So for now, just focus at this one. What is the acceleration? S is not even given at that point. Okay, but yeah, I just read it. A car accelerates steadily so that its velocity changes from 20 VI, 40 VF, 4 times acceleration A. We got these 4. We cannot deal with all 5 variables at the same time, so we just pick 4 and solve that first, and then we worry about the rest of the problem. Okay, so for now we have our hands full, and we need to solve this first. Now let's let me copy this and take it to the next page. So we seem to have consensus now that it is going to use first equation of motion, and first equation of motion is VF. Let's go. It is lowercase v, but for now I'm using just uppercase. VF is equal to V I plus AT, and VF is equal to 40 is equal to VI is 20 plus A is what we don't know, and T is 4 seconds. Okay. So we just rearrange that. I do it in steps. 8, 4 is equal to 40 minus 20 is equal to 20. And now I divide both sides by 4. So A is equal to 5 meter per second squared. Okay, so now we have solved this much. And then the second part. Now let's clean this. How much distance did the car cover during this time? Now we are involving S as well. At this point, we know VF, VI, A, and T, and we need to find out S. So it is really up to us if we want to use second equation of motion or third equation of motion. Doesn't matter. Because if we take second equation of motion, we know VI, we know A, we know T. For third equation of motion, we know VI, VF, and A. So using both, we can find S. So please solve it and let me know what do you get. What do you think? What is the displacement basically covered during this time? Give us 5. Mm-hmm. Anyone else? Okay. Let's check. And here is our solution. Increase the font size. Now I'm going to use second equation of motion first. So S is equal to, what is VI? That is 20 multiplied by time is 4 plus half multiplied by A. A is 5 multiplied by time is again 4. 4 squared is 16. So 16 multiplied by 5 is 80. 80 multiplied by 80 half is 40. So this part comes out to be 40, and that part comes out to be 80. Am I doing something wrong, or you did something terribly wrong? Is equal to 120 meters. Now let's use third equation. 2 multiplied by A acceleration is 5, and S we need to find out is equal to Vf squared. Vf is 40, so 40 squared will be 1600 minus Vi. Vi is 20, so 20 squared will be 400. Yes, okay. And so 200. Excuse me. 2 multiplied by 5 is equal to 10. So 10s is equal to 1600 minus is equal to 1200. So S is equal to, divide both sides by 10, 120 meters. Does it make sense? So very simple problems, but it is the same easier to mess it up. So yeah, I know things go wrong. Why is the distance S? Just convention. Doesn't really matter, because when we say X, Y, or Z or Z, we imply that it is along a certain axis. But when we use a neutral letter S, then we are not really irritated about that. We're essentially telling that we don't care what axis this is along, but did I answer the question you asked? No. Vi, velocity. Vf, again velocity. A, acceleration. T, time. S. Okay, now I got it. S, initial is speed. Yeah, I know. But no, it is not. There is no specific letter for speed. Yes, S is displacement. Yeah. Because now we are in the vector regime. In the vector, speed is nothing. We don't understand what speed is. We only know velocities. And that's why I was saying that I'm using distance here a lot, but it is actually displacement. It is all vector regime. So velocities, acceleration, displacement. No speed, no distance. Okay. Sorry for my part in this confusion. Okay. Now we'll solve just one more problem and then we'll finish. A stationary block. Okay, what information do you get from here? A stationary block. These three words. It tells you something about one out of those 5 variables. 0 what? Time 0, displacement 0, final velocity 0, acceleration 0, or initial velocity 0. What do you mean? Okay, yes, exactly, very good. A stationary block, so the point where we paid attention to that poor block, it was stationary, so our scope starts right there. At that point, the initial velocity is 0, at rest. Okay, a stationary block is blocked from. So now what information we get? Another variable out of these 5. is dropped. Is dropped. What information do we get out of? Okay. Anyone else? Trista, that is next. I'm talking about the word dropped. What information do we get out of this word? Dropped means you are just throwing it downward. It means it is going to just fall under the influence of gravity. So acceleration is equal to G is equal to 10 meters per second squared. Okay, very good. A 125 meters high shelf. So it means that our scope will involve a displacement of 125 meters downward. Okay. How long will it take to hit the ground? It means the time is something we need to know. Need to find out. So Vi is equal to 0, S is equal to 125, A is equal to 10, T we need to find out. Vi, S, A, and T. Which equation of motion can help us? Let's grab it from here and check it to this slide. Now tell me which equation, first, second, or third? We got problem with third. Third equation involves Vf. We neither know nor require Vf. So Vf is irrelevant in this story. Exactly, no T, we do not have. But that is not important. What do we have? The important part is that in order to use the third equation, we need to either find out Vf or we need to have Vf, and both are not the cases. So third one dropped. First, the problem with the first one is S. We do not have S there, and also Vf again bothering us. We do not know Vf. If we need to know time and we don't, okay. Another problem with the third equation is we are trying to find out time, and third equation does not have any time. So that is useless, right? Okay, with first equation, we don't know the time, we don't know the Vf, we have two unknowns, we cannot use this. And why don't you people like the second equation? It is so lovely, so beautiful. You can use that. So Vi is there, S is there, Vf is equal, no, we don't know that. There is a reason. Very good question actually. When you hit, you drop a box, it hits the ground. After hitting the ground, a few moments later, it will come to a stop. It will be 0. So there is nothing to really find out. The moment at which it touches the ground, that is the velocity of our interest. That is our Vf. Not the one that it settles at after hitting. Okay? So Vf is the moment at which, because Vi is already 0, Vf is, if Vf is also 0, then what is there to find out? Nothing. So it is the velocity at the moment it is about to, or it has just touched the ground. So that is the maximum velocity actually. So second equation of motion is what's going to help us. S, we know that. Vi, we know that. T, we need to find out. Half, A, we know that. T, again, we have to find out. So second equation of motion is over here. Just put these values, solve it. 5 seconds is the answer. Okay. So don't assume things. Keep your mind open, open for any possibility. And again, don't assume anything. Just my favorite method is to looking at the problem and then just write down Vi, Vf, S. Something there happened. Hope no one was on there. Okay, so now just write these down, these 5 variables, and now start figuring that what variables do you have and what do you need to find out. Okay. And again, for the exam, for physics exam, you will be allowed to use paper for calculation. You will also be allowed to use calculator. Usually this is not the case with your other exams. Okay, in physics you can use that. So on the paper, just scribble VIVFSAT and just start reading the statement and start crossing the things out, and then you know what variable you are dealing with. So that was all for today. I will deal with other problems tomorrow. If you have any question or confusion, let me know. No question. We all want to sleep. Okay, good. Okay, have a good night. I'll see you tomorrow. Bye for now.